Hello everyone, welcome to our program with C++ video lesson. In our first lesson video, we get to know what C++ is all about. Before that, I'm Steven, and these are objectives for today's lesson video. Now, let's talk about what we are going to accomplish by the end of this video. You have a solid foundation in several key areas. First, I'll introduce you to C++ and understand what makes it special. Think about it this way. It's like meeting new friend. We want to know who they are and what they are good at. Second, we will explore sorry. Second, we will explore why programmers around the world choose to use C++. Is it because it is popular? No, because I have practical reasons why companies like Google, Microsoft, and game developers like Unreal Engine use C++. Third, we will compare C++ with its processes, the C programming language. This is like understanding the difference between a car and a more advanced car with extra features like Tico with Ferrari. Finally, we will dive into object-oriented programming, OOP concept. Well, it's a bit complicated, but we get into it and we understand it better. Continue with the objectives. We also explore the standard library components, particularly the IO stream, which the IO stands for the output and input. It basically talks about how the user talks to the user and how the user talks to the program. I walk you through the C++ programming develop process flow. And this is the step-by-step process of how you turn your ideas into working programs. You also learn about the difference between processes and threads. Think of process as a different applications running on your PC and the thread as different tasks within those applications. Finally, we also get our hands on experience with code blocks, which is the software I will use to write and test our code. We have different IDEs and editors like the VS Code, C Linux, and others. Now let's go get into what C++ is. Before that, I would like to give you some brief history about the C++. The C++ was created by a brilliant computer scientist named Bijan Strasberg in 1979. It's about 50 years. Initially, it was called C with classes. If you're wondering what classes mean, don't worry, we'll explain that later. The C++ was actually coined by Rick Mascitti in 1983. The plus plus in programming means it's a symbol that means add one or make it better. So C++ actually means or simply means C but better. The language was commercially released in 1985 and it evolved from C programming language in 1998. International standards were established to ensure C++ worked same way across different systems worldwide. That's the AXI, ANSI, and the rest. One common question every beginner asks, why should we use or why should I use C++? Now you might be asking same question. There are so many programming languages out there. Good question. First, C++ is used in virtual every computing system you can think of. From your smartphone to your biggest supercomputers, C++ is there making things work. Second, C++ supports object-oriented programming, which we will explore in detail. This makes it easier to organize and manage complex programs. Thirdly, it's incredibly efficient and close to the machine. This means C++ program can run very fast and use computer resource effectively. It is what we call system programming language, perfect for building operating systems, games, and high-performance applications. Fourth, C++ program is a compiled language, which means your code gets translated into machine language before it runs. This makes it faster than interpreted languages. And last but not the least, C++ allows you to write modular programs that can work on various platforms like Windows, Mac, Linux, and more. When we say a programming language implements OOP or object-oriented programming, we mean it provides tools and features that makes it easy to create work and objects. As you are learning C++, you discover three important things. First, how to represent data in computer memory. It is like learning how to store information about your car or about your car. Second, how to manipulate data, like changing the car speed or fuel level. And third, how to implement operations like actual codes and that makes the car accelerate. You also learn how to write algorithms, which are the step-by-step instructions for solving problems in programming, and implement them in C++. Now, the key insight of the object-oriented programming is learning how to combine data and operations into single units called objects. This is a revolutionary because it mirrors how we think about real-world things. C++ was specially designed to implement object-oriented design, the OOD. But here is something important: OOD doesn't replace structured design. It works together with it. Think of it as adding new tools to your toolbox, not throwing away the old ones. Finally, key concept of polymorphism. This Greek word means many forms, and it's actually simpler than it sounds. Polymorphism means that the same instructions can have different effects depending on the context. For example, if you tell different vehicles to start, a car starts its engine, a bicycle doesn't need an engine to start anything, and an electric vehicle starts silently. Same instruction but different implementation. This makes your program more flexible and easier to extend with new features. Now, this is the how the basic structure of a C++ looks like. The basic structure is a hash include IOStream using namespace std, then you terminate it with a semicolon. Int main, the cout, enjoy yourself with C++. Now, before that, the first line, this line, the hash include IOStream, tells the compiler to include a library for input and output operations. It is like important tools you need for your programming. And the second line, this line, using namespace std, it's like saying I'm going to use the standard set of tools so I don't have to write the std every time I'm writing the code. And the int main, this is where your main program starts executing. Every C++ program must have the main function. And the C out, this one, the C out, is used to display text on screen. And this sign, the insertion sign, insertion symbol, direct the text to output. And the end line, the end L here, means end line. It's like pressing enter on when you are typing on WhatsApp, or maybe you press enter to go to the next line. And return 0 tells the operating system that the program has finished successfully. Now, processing a C++ program. Let's understand what happens when you want to run a C++ program. This is a step-by-step process, like following a recipe or something. First, you use an editor to create your source code or program. This is just a text file with your C++ code, like an example we just saw here, this one. This example here, this is a source code. Some statements in C++ begin with hash, like the hash include. This hash include, like the hash include. These are called preprocessors directives, and they are processed by a special group called the preprocess before your main program compiles. Next, you use a compiler to check that your program follows all the C++ rules and translates it into a machine language. If there are errors, the compiler will tell you what is wrong. Finally, you might use software development kit or SDK, which provides additional tools to create programs. When the compiler see an error and tells you have to fix that error before the code can run. Otherwise, the code will never run. The process continues with two more important steps. The linker combines your compiled program with other programs provided by the SDK to create executable code. Think about it this way. It's like gathering all the pieces you need to run your program. The loader then loads your executable program into your computer main memory. And finally, it executes or run your program. This is when you see your program actually working. The linker. This is a diagram to show how the linker, the processes, and loader, everything works and executes. Now, compiling and linking. We dive deeper into the compiling and linking process. This is like the quality control of a company. First, you run your code through the compiler. If the compiler finds an error, like typing mistake or incorrect syntax, it will generate an error message. When you see these errors, don't panic. It's normal thing we all face. It's once you're a programmer, you face these errors. You have to go through the error, then correct it through the compiler again. If there are no syntax error, meaning your code follows all the C++ rule, the compiler generates equivalent machine code. This is the code that the compiler directly understands and executes. And finally, the linker connects your machine code with the system resources. creating a complete runnable program for your program. Now the loader and executing. Once your program is compiled and linked, the loader can place it into the main memory for execution. This is like loading a game into a PS2 console. You need to put a CD in the console before you can play the game. That's how this thing works. And the final step is executing the program. This is when the code actually runs and does what you program it to do. And this is something important you need to remember. This is like note NB. Here is something important you need to remember. The compiler guarantees that your program follows the rules of C++ language, but doesn't guarantee that your program will run correctly. You could have a program that follows all the syntax rules but still doesn't solve the problem you wanted it to solve. This is why testing is important. Processes. Understanding processes. Now let's talk about processes. A process is simply a program that has been loaded into memory along with all the resource it needs to run. Think of it this way. Your C++ source code is like a recipe. When you compile and run it, it becomes a process like actually cooking a meal using a recipe. Each time you run a program, you create a new process. If you open the same program twice, you have two separate processes running. Threads. A thread is a unit of execution within the processes. Like I said earlier, that threads are threads are units of execution within the processes. If a process is like a company, then the threads are like the workers, individual workers in the company working. Multiple threads can be created from single process. Some processes are single threaded. They do one thing at a time, and others are multi-threaded, like multitasking. They can do multiple things simultaneously. This is particularly important in modern programming, where we often want our program to do several things at once, like playing game, playing music same time, while downloading other stuff and responding to user input. And this is the visual representation of the thread. The visual representation of the thread. Threads and processing in programming. Let's trace through the complete journey of program from the idea of execution. Everything starts with a text file containing your program code, which is the source code. This is what you type in your diary. Next, your program is compiled and interpreted into binary form, that is zeros and ones. That's what the computer uses. Binary is a language that is the computer uses, and it understands it. Then your program is then loaded into the main memory where it's ready to run. The journey continues as your program becomes one or more running processes. Remember, processes are typically independent of one another. They have their own memory space and resources. Within each space, within each process, thread exists as subsets, like it's a subset of the processor. Think of threads as a different task that the process can perform. Yes. And here's one key point. Threads can communicate with each other more easily than processes can. This is because threads within the same process share the same memory space, while processes are isolated from each other for security and stability reasons. Now, in conclusion, we have covered a lot of ground today. We've learned what C++ is, why it's widely used, and the fundamental concept of object-oriented programming. We've also explored how C++ programs are processed, compiled, and executed. And we have introduced the concept of processing and threads. Don't worry, everything doesn't click immediately. Programming is like learning a new language, and it takes time to practice. In our lesson video, we will start getting our hands on some codes within the code blocks and write our first program. I will encourage you to review these concepts before our next session. If you have any question, please don't hesitate to ask me or comment. Thank you very much. Have a nice day. See you in the next video.